Everyone, my name is Punit. I am a student of Mechanical Department of IIT Delhi. This video is about electric vehicle battery, and this video is a part of course automotive systems. Let's go through it. So these are the things that I will gonna discuss in this video. First, I will discussing about the introduction to electric vehicle. Then I will discuss about the why do we need the electric vehicle. Then I will show you some vital parts of an electric car. Then I will be discussing about the battery of an electric vehicle. Then I will show you the position of battery pack in electric car where it is situated in an electric vehicle. Then I will discuss about the battery pack and what are the important components of a battery pack. What is the inside the battery pack. Then I will be discussing about the battery management system. So first one is introduction to electric vehicle. Uh, so let's discuss what is electric vehicle. Basically, electric vehicle is a vehicle which operates on an electric motor instead of IC engine. Talking about the history of an electric vehicle, first electric vehicle was built between 1832 to 1839. The exact year is uncertain, and it was built in Netherlands. Also, that was a car, and here a picture is shown. Here, electric car is shown with the electric charging point in this picture. Next is why do we need electric vehicle? What are the reasons so that we want electric vehicle instead of a few petrol and diesel fuel vehicles? First one is cheaper to run and maintain. Owners of electric vehicle have the advantage of much lower running costs. According to a study, the electricity to charge an electric vehicle works out around a third as much per kilometer as buying petrol for the same vehicle. A battery electric vehicle has a load less moving part than a conventional petrol diesel car. This is relatively little servicing and no expensive exhaust system. Starter motors, fuel injection system, radiators, and many other parts that are not needed in an electric vehicle. Next is better for the environment. It's a clean alternative as compared to petrol and diesel vehicles because an electric vehicle has zero exhaust emissions. There are health benefits. Reduce harmful exhaust emission is good news for the health, for our health and also for environment. Better air quality will lead to the less health problems cost caused by the air pollution. Electric vehicles are also quieter than petrol diesel vehicles, which means less noise pollution. Then we can fill it at home. Now I will discuss about the vital parts of electric vehicle. Vital parts mainly include the transmission system, motor, controller, battery management system, and the battery pack. This is about the battery of an electric vehicle. Usually, these batteries are usually rechargeable batteries or secondary batteries. These batteries are specifically designed for high ampere hour current or kilowatt hour capacity. These are smaller, lighter batteries. These smaller, lighter batteries are desirable because they reduce the weight of the vehicle and therefore improve its performance. As compared to the liquid fuels, most current battery technologies have much lower specific energy, and these often impact the all electric range of vehicles. This is the issue that we need to tackle about the electric vehicle. Then there are different type of batteries like lithium ion, lead acid, nickel metal hydride, and many more. Among these, the most common battery type in modern electric vehicles are lithium ion because of their high energy density as compared to their weight. So next is the position of battery pack in an electric car. This is a picture of an electric car. In this picture, you can see the battery pack which is placed at the bottom of car and in between the front and rear wheels. Next is battery pack. Basically, battery pack is a collection of batteries which are connected in series and parallel according to their requirements. Here you can see the cell at the bottom of the picture. The cell refers to a single battery. There are many different sizes and shapes for a cell based on the chemistry. Most commonly used chemistry is the lithium batteries, as I already told you. The voltage rating of the cell will be anywhere from 3.7 volt for a lithium batteries, but this voltage is not enough to run an electric car. The Tesla, for example, has a battery pack of voltage of 356 volts. So to get the higher voltage from 3.7 volt lithium cells, battery packs are used which are formed by combining more than one battery together in series and parallel combination, and this is known as battery module. You can see the second thing that shows the module part. uh, so once the battery modules is ready, it should be connected to the BMS, that is battery management system, and a cooling system for safe operation of battery. The complete setup is kept in a steel casing to prevent mechanical damage. This complete arrangement, along with BMS cooling system, casing, and the battery modules all together, is called battery pack of a car. These packs these packs will normally be big and occupy the entire floor area of an electric vehicle, as shown in the previous slide. Now let's look inside a battery pack. Battery pack designs for electric vehicles are complex and vary widely by manufacturer and specific applications. However, they all incorporate the common combination of several simple mechanical and electric component systems, which perform the basic required function to offer the pack. Battery modules can incorporate cooling mechanism, temperature monitors, other devices. In most cases, modules also allow for monitoring the voltage produced by each battery cell in the stack by using a BMS or battery management system. The battery cell stack has a main fuse which limits the current of the pack under a short circuit condition. Next is, next is service plug. A service plug can be removed to split the battery stack into two electrically isolated halves. With the service plug removed, the exposed main terminals of battery present no high potential electric danger to the service technician. The battery pack also has relays or contactors which control the distribution of battery packs electric power to the output terminals. In most cases, there will be a minimum of two relays which connect the battery cell stack to the main positive and negative output terminals of the pack, which then supply high current to electric drive motor. For safety reasons, these relays are normally open. Next, the battery pack also contain a variety of temperature, voltage, and current sensors. This is a battery pack shown with some important parts along with numbering. Numberings are given just for easy to understand. The number one is um, so this is a battery pack shown with some important parts along with numbering. Numbering are given just for easy to understand. Number one is battery assembly adhesive, uh, which is mainly act as a glue to join batteries, and it also enables cost efficient and fast assembly of prismatic cylindrical or pouch cells. And the number two, here you can see the thermal gap filler. Thermal gap filler materials are essential for efficient heat management, safety, and lifetime performance of the battery. They allow for extremely fast and automotive dispensations. The third one is thermal adhesives. Thermal adhesive offers a unique combination of thermal conductivity, structure strength. In addition, the material can be applied in an automated process and cures at high speed. The fourth one is at the bottom. You can see liquid gasketing. Liquid gasketing technology for battery pack housing enables lifetime reliable sealing against environmental influence and fluids. The fifth one is the just below the number 4, battery structural adhesives. It also act as a glue to join protective cover or structure. The number 6, you can see the right top corner, metal treatment. Metal treatment technology protects battery pack housing against corrosion. They have been designed with an aim towards lowering environmental corrosion impact by reducing energy consumption and waste generation. And the number 7 is conductive coating. Conductive, it's basically improves the charging and discharging performance of lithium-ion battery cells by reducing the electric resistance between active material and aluminium. The last and eighth one is impregnation service. It offers a permanent sealing solution to the potential porosities in aluminium casted battery cover. Uh, in this slide, these are the points which I discussed in previous slide with the help of the picture. And the next is battery management system. It's like the brain or caretaker of batteries. The BMS is also responsible for communication with the vehicle outside the battery pack. Basically it's an electric system, electronic system that manages a rechargeable battery. The main functions of BMS are to monitor the state of battery as represented by various items such as temperature, voltage, current, etc. Then next is thermal management. Thermal management means to deal with battery temperature with the help of cooling mechanism. Next function is computation. Computation to computation helps to maintain the threshold values of temperature, voltage, and current. Next is protection. BMS may protect battery by preventing it from operating outside its safe operating area, such as over voltage, under voltage, over current, etc. And the last one is optimization. In order to maximize the battery's capacity and to prevent localized undercharging or overcharging, the BMS may actively ensure that all cells that compose the battery are kept at the same voltage or state of charge through balancing. So that's all. Thank you.